Hello, D. Alfred Ostrowski. In this recording, I'm going to be demonstrating your very first Hello World style implementation of a Solidity smart contract. I'll be running it from the command line on the Hardhat personal blockchain, and I'm running it on an EC2 instance. And I've already assumed that you've followed through the instructions, and if you haven't had the prior software installed, that's indicated on the associated GitHub. I have a video explaining that and running through that, and I'm going to include a link to that on the associated GitHub with this video. So again, I'm assuming that you've run through the steps, and I'm pulling off the page here that has the day one of my 20-day challenge. And I already assume that you've installed the following software here. And I'm going to just cut paste through the commands and explain it as I work through this. This is going to happen very fast. If you have no prior knowledge, you're going to be able to walk away with this if you have it up and running and work through the installation process. And the time that it'll take to watch this video, you'll be able to cut and paste and run your own smart contract and see you've done that. So let's go ahead and do it. So I have my EC2 instance. It's a C5 large instance, as indicated in the documentation. I have two terminals up. You can use whatever kind of terminals you'd like. I use Putty. It's been around forever and a day, and it works exactly the way it's supposed to, right? So I'm in the home Ubuntu directory. The first thing I'm going to do is create a project directory. I'm just going to call it Hello World. Do a make dir as such, and I'm going to cd to my directory, just like that. Now I'm going to do an npx hardhat init. Now this is going to both download Hardhat sorry, I have to spell it right. So this is going to both download and install Hardhat, unlike the npm is going to do an npm install. npx downloads and installs the software. Since we're running a C5 large instance, it's going to install very quickly. And then as you noted, I defaulted just hit return through the prompts. And again, we're not going to use a web front end. We're going to invoke the smart contract from the command line. And as I proceed with some of the following videos, I'm going to be kind of using this as a technique to both test out my smart contract in some cases, perhaps run some assertion testing, as well as support the activity of debugging. So it's almost done. Just going to give it a couple few seconds. We don't have to pause out the video because again, C5 large runs pretty fast. As you notice, the installation just completed. So now I can proceed. So now that I'm in the directory, Hardhat gave me a somewhat of a project directory here, and I'm going to go to the directory appropriately titled contracts. I'm going to use the VI editor, and I'm going to do VI hello.solidity. If you're not familiar with VI, okay, I'm going to include some related information that you can go in and become familiar with it, or you can use any kind of editor you like. The reason I use VI is because I'm not going to be doing a lot of fancy editing in this video or a number of the videos that I'm presenting. And it works. It does what it's supposed to do. And most importantly, I have to install it because it's already pre-installed on both Ubuntu as well as any other Linux. So let's take a look at the smart contract before I save it and we start to execute it. And we'll review this again a few times as we examine it in a couple more videos where we expand on the experiments here. But you see the contract starts with the keyword contract. I've named it hello appropriately. And you'll notice if you have any programming experience, this has a basic C style syntax, or Java, C#, and so forth. It has the same type of format. I have a single string. It's stored as a public. I call it stored data. We're going to be generating an event. We're going to be dealing with this a little bit later, but This is included right here. It generates an event to a log file. And we'll take a look at it in further tutorials as to how to read the log files and how it could be leveraged for your debugging and managing and checking on events. And I got two functions here, a set and a get, your classic object-oriented type methodologies where I'm just simply setting a string and getting it through the use of a method that is available publicly. I'm going to pass in string memory my text as a public and also get is as a public. Now with the blockchain, we have money that is going to be allocated to an account, and we spend money to write to the blockchain, and we don't have to spend any money to read from the blockchain. We'll examine that in more detail as we proceed with this example and some more advanced examples. So I assign my text to stored data, and in the get, it returns the stored data. In the set, it generates an event. And this is taking that text and calling the event appropriately defined and just sends it as output. So interestingly, with log files, it's separate as storage, but it's a different type of storage. It's a lot cheaper and it doesn't allow access from smart contracts. So more about that as we proceed. Let's just get it up and running. Okay, so I've saved that smart contract. And now I can proceed with my instructions. And again, everything is on the README install with the associated GitHub. So we're almost done. Okay, this is going to happen really fast. So next thing I'm going to do is start up my node. So Hardhat is both a development environment and a simulator for a blockchain. So this generates a blockchain on my local node. So it started up the blockchain and it gives me 20 accounts. And this is on like a local host. So I just use the hostname localhost, and I'm not going to be accessing from the outside. So I didn't have to specify DNS because technically I'm running this up in the cloud on my Ubuntu server, just allowing for an easy means of transferal that you'll be running it, run exactly the same way that I'm presenting it to you. So I have my 20 accounts. I have an account number and a private key. I have 10,000 ETH. Unfortunately, this isn't real Ethereum currency. This is the play ETH that comes with the smart contract. So this is up and it just sits there like any type of network server, and it's waiting for me to perform transactions on it. Okay, so now I can go into that directory. Now when I'm doing these commands, notice I run it in the local directory, because otherwise it's not going to know where you installed Hardhat, because that's where I installed it. So now I'm going to bring up the console. I do this by running npx hardhat console on the same local network. So here it compiled two Solidity files, and here it compiled most importantly, my hello.solidity smart contract. So I can do a number of things now. And if you notice with the installs, I installed the ethers library, and this allows a lot of immediate access to smart contract, whether I'm going from a decentralized application or from the command console. Here, I'm going to call up the provider get balance, and I'm going to grab that balance and I'm going to read it from the command line. And you notice the blockchain was queried and invoked with the get balance, and the account I'm checking here, ending with 92266. If you notice, that's the first account here. Okay, and I had it hard coded, and I wasn't a good guesser, right? It always comes up with the same named accounts. Of course, this is just a simulator, so there's no purpose in generating unique accounts and private keys, because again, this is a test environment, so you can test out your understanding of Ethereum blockchain and writing smart contracts before you even go to a test net or the Ethereum mainnet, which is very cost prohibitive if you wanted to do a lot of learning exercises and testing. So let's proceed. And again, I'm just cut pasting from my notes here. I can grab, using the ethers library, I can pull in all the signers. That's ethers get signers, and I'll pass it the associated variables. And I can grab the first, it's going to give me that same account, and you see the address 92266. And I can do another way. I can just take that same value and I can pass signers as such, and it gives me the same balance, right? So now let's deploy the contract. I'm going to do ethers library again, and I'm going to use it to deploy my smart contract to my personal blockchain. So I'm going to use ethers get contract factory. Notice looking at that contracts directory, it's going to deploy, and we use await for these calls to allow it to run in asynchronous fashion. And per its name, we don't have any race conditions when it assigns it to the variable. It's not going to assign it until it actually returns because it runs in asynchronous fashion. In some cases, it could make an assignment of that variable before it actually completes. So that's why we use await. Okay. Otherwise, and if you use it in a decentralized application, you may have inconsistent results. So you have to remember to use the await. So if I do contract that's being returned, then I see a definition here that's in a JSON-based format, and I have an interface defined, and it has the associated bytecode with the hello.solidity. It has an address of the signer. That's because the signer deployed it. And interestingly, I can go back to that signers. And if I do I didn't deploy it yet, so I'm going to grab the balance now, and then now I'm going to do the deployment. So I'm going to do contract deploy, and then we're going to check the balance. I got a little bit ahead of myself here, so I'm going to do contract deploy. If you see here in the back, it deployed it and has gas used, and that's the amount that it cost me to write to the Ethereum blockchain, okay? And you got to remember, this is in ways, so it's 17 digits lower than the Ethereum smart contract money, right? So here we can print CD. I have the associated money, or I'm sorry, characterization of that contract. And then I can check the balance again, and I have less than 10,000 because it was 9999999 because it took that very small amount. It cost me to be the deployer account. It cost me to write to the blockchain. So now I can run my smart contract, okay? And I'm going to just do my set and get. So I can do await, CD, set, and I could say anything, right? So typically what I can say, hello world. And you see in the background, it's writing it. And every time it's writing it, it is sending a transaction, and it's generating new blocks, okay? And per understanding the blockchain, right, every time you're writing to it, it's generating new blocks to store that information. Now I can do a get, and it'll retrieve that data. So I can do CD get, and it's going to retrieve that call. You notice there was no gas used for the ETH call, and there was no blocks generated. And I can do another set and I keep on going, right? And I can say hello world again, perhaps. And you can see it updated again. I do the get. So there you have it. So again, what's the difference between using a programming language such as Solidity and writing in any other type of programming language? Okay, in this case, we're writing to the blockchain, and for starters, we don't write to standard out. We have to use JavaScript, okay, to print it out, whether it's through a JavaScript front end, such as React.js, or at the command line is used here. We're still using JavaScript, okay. But I'm writing it to the blockchain, and I can use the Ethers library to get those blocks, okay, and actually pull out not just the last piece of data that in most cases, if this was any other programming language, the first call would be just overwritten and then that memory is not accessible. But here I can grab that first block, all right. I'm going to do the second block because that is the block from where I wrote the first string, okay, to my variable. And I can use that to grab the actual transaction information. I compare that down. and I can use the call prefetched transactions, and let me just pass it into another variable here. And if you notice here, that data, now it's encoded, but I can decode that data. But what I'm doing here is really reading my personal blockchain block by block. Okay, so this illustrates the power of the blockchain. Anytime you write to the blockchain, it's always written to the blockchain and remains as such, and it's immutable. Okay, it's never going to be changed. It's always going to, that historical information will always be there to be accessed. And without getting into too much detail, then it's easy to understand or appreciate that I have that data is being stored. So here I do a conversion from a hex style format that's stored internally by using a U to UTF 8-string call in the ethers library. And you can see here the formatting is a little bit less than perfect here. And we could format and pull out these extra characters, but you can see here that the actual information was stored on the blockchain. And I can even read the second block by going back here and grabbing the third block that was associated. Okay, whoops, I don't want to do that to the same variable because I set it as a constant. So it's called B3, and then I can call the B3 prefetch transactions and then print out D2 as such. And I can see the hello world again. So there you go. So what did we do? We started up, first installed and started up the Hardhat blockchain simulator and development environment by creating a Hardhat project. We started up the Hardhat console after actually inputting a hello.solidity smart contract. Once we started up the command line, we brought in the smart contract and deployed it from the command line, and we invoked the methods. We also read the blockchain to read the values, not just that were last written, but were written initially, and you could go back any level and pull any type of information. And as you get into more sophisticated implementations, there's numerous libraries and methods of pulling out transactions and following through all the transactions that occur in the blockchain. So, but this is your starting point and your understanding and appreciation of how Solidity works, and most importantly, engaging with it with a hands-on procedure. So thanks for listening. Hope this helps, and more to come on the further videos. Thank you. Take care. Bye now.